Hello, in this video, we will solve problems from in-class exercise 4, chapter 12 using normal tangent coordinate system. Now, the first problem in this in-class exercise is still a Cartesian coordinate system problem where x and y are given as a function of time and we need to calculate the velocity and acceleration at t equal to 1 second. So you can apply the Cartesian coordinate concepts for velocity acceleration calculations and look at the solution that is being provided to you. Now this problem is regarding normal tangent coordinate system because particle is traveling along curved path. So let's work on this problem. So determine the acceleration at the instant zone where the velocity of the particle is 2 meters per second and tangential component of the acceleration is 3 meter per second square. So that's the problem statement. Now we need to calculate total acceleration of the particle using normal tangent coordinate system. So first step is we set up our coordinate system. Arrow indicates the direction of travel of the particle. So tangential axis is always tangent to the curved path and normal is always towards the center. So we have defined our normal tangent coordinate system and unit vector in the tangential direction is ut, unit vector in the normal direction is un. And the radius of curvature, that is distance of particle from the center, is given as rho equal to 1 meters. So this is the radius of the circle here. So now we need to calculate both tangential component of the acceleration, which is at is equal to v dot. We don't need to calculate it because it's already given, is 3 meter per second square. And an, normal acceleration, is v square divided by rho. So these are the two formulas that we will use for normal tangent acceleration calculation, where v square is the velocity at that point, which is 2. So it's 2 square divide by radius of curvature, which is 1. So it's 4 meter per second square. So this acceleration is at, this acceleration is an, and total acceleration is vector addition of these two, which is a. So total acceleration a can be written as at ut plus an un, where at is 3 ut, where ut is the unit vector, and 4 un. So that's the vector representation of total acceleration, and it can be calculated. The magnitude of that acceleration can be calculated as square root of 3 square plus 4 square, which is nothing but square root of 80 square plus an square, and that's 5 meter per second square. That is the total acceleration of the particle. Let's go back and work on the next problem. So for this problem, let's select well 136 from in-class exercise 4. At the given instant, the jet plane has speed of 550 meters per second. So V is 550 meters per second and an acceleration of 50 meters per second acting in the direction as shown. So acceleration that is given to us is in this direction, and that is 50 meters per second square. Determine the time rate of change in plane speed, which is v dot, or this is also called the tangential acceleration, time rate of change of plane speed, and also the radius of curvature of the path, rho. So we have two unknowns that we need to calculate from the given information. Now the acceleration that we have been given is the total acceleration, not normal nor tangential. So first step, you set up the coordinate system. So we define tangential axis in this direction because plane is speeding up. Normal axis is in this direction, always towards the center of curvature. This is tangential component of the acceleration, and this is normal component of the acceleration. And what we have been given is the total acceleration a, which is 50, and we know this angle 70 degrees. So we can apply the trigonometric concept, and a cosine 70 is the tangential component of the acceleration, because cosine closes the angle and sine opens the angle, and a sine 70 projects the acceleration along the normal direction. Okay, so first step is calculate AT, which is a cosine 70, and then the next one, and it is by the way, this magnitude a cosine 70 is 50 cosine 70, which is 17.1 meter per second square. This is the unit for acceleration. And an is a sine 70, which is 50 sine 70, and 70-degree angle is given to us here. And this is 46.98 meter per second square. So we have already solved for one of the unknown v dot, which is this. So at is also v dot. So v dot equal to at equal to time rate of change of plane speed, which is 17.1. How do we get the radius of curvature? So for that we use the formula for normal acceleration, which is v square divided by radius of curvature, which is 550 square divided by radius of curvature, and an is calculated as 46.98. So this thing is equal to 46.98, and from that we can calculate radius of curvature, which is 550 square divided by 46.98, and that's the big number, 6,440. So we can write that as 6.44 kilometers. See, we are using here prefix like kilometer because it's more than 1,000. The actual answer is like 6,440. And we have solved the problem. So we have calculated both the unknowns. And this problem that we haven't discussed here, where velocity is given as a function of time for the boat, and we need to calculate the magnitude of the total acceleration of the boat when time is 10 seconds. So normal tangent coordinate system is defined for us. So first step is you calculate the speed of the boat when time is 10 seconds by substituting t equal to 10 in this equation. That gives us the value of v. Then next step is you take the derivative of v relative to time. So you take dv by dt, and in that equation you substitute t equal to 10, and that gives the tangential component of the acceleration. And normal component of the acceleration will be v square divided by radius of curvature, which is 40 meters given in the diagram. And then you apply the same strategy by calculating separately normal and tangential component of the acceleration. You can actually apply the same steps that we have applied here. You can write the total acceleration as a vector and calculate the magnitude. So try to solve this problem yourself.